Hello everyone, welcome to Raccoons online workshop number 4. This time we will learn about backend development using Python language. My name is Chris. I've been a developer for 12 years now, and I have been working with languages like JavaScript, HTML, CSS, comes together with that, Python, Java, C, C++, PHP, many databases, SQL and NoSQL databases, and many other areas as well. On top of that, I have been working in multiple hackathons, 15 or more, both as a mentor and as a participant. So the idea is to get yourselves prepared for whatever ideas you might have in a hackathon and be able to develop them. Front end is important, but so is the back end, so that your application can work, so that you can store something in a database, and so that you have an API that you can call from front end. So let's dive in. We will have an overview over the different programming areas of front end. I would assume that you're more or less familiar with that, what you have been doing in previous workshops. This time we will be working with backend, but there are several other areas as well. I will give a quick overview also over the programming languages that are out there, so that you understand the scenery in programming, and what have you tasted so far of that big pie called programming. And finally, today we will try to set up the environment. It turns out that when you do JavaScript, it comes bundled into a browser. The thing that runs JavaScript is a browser. So it's not that clear what runs Python. Some of the operating systems have Python installed, so you can just run random code that you get in the internet or that you will develop in this tutorial. But it's not said that it must be like that. So you might need to check what Python version you have, or if you do have any Python version, and if not, you have to set it up yourselves. So our goal for today is to actually run the simplest Python code we can, and in the subsequent tutorials we will try to make an API that you have been working with some open APIs in previous workshops, as I understand. So we will make our own API this time. So I found this picture in the internet, front end versus back end, and it says that 20% of the programming power of a legit project goes into a front end and 80 into the back end. Well, I wouldn't necessarily say that every project has this distribution. I would say that some projects may be more front-end intensive than others, but this picture more or less shows that backend is extremely important in most of the projects. And what I like about this picture is that over here there is this thin line, the water line, where this iceberg is divided between front end and back end, and it's connected via the API. And you have been using APIs in the previous workshop, so this time hopefully we will manage to connect our front end with the back end via an API as well. But it's not just backend and front end. There's also databases. Database is, well, more or less all the data that you have. The code itself rarely contains data. So it's just the instructions how to work with data. But data has to come from somewhere, and that somewhere most of the times are the database. You can fetch it from some external API, but this API has a data in their database. So it's when the application becomes bigger, the databases also become bigger and harder to maintain. And it's important for, I don't know, Facebook or Twitter to be able to pull out the exact pieces of data with a split second speed. And when you have million or even billion rows in your tables, it becomes harder and harder to accomplish that, especially when your database is distributed over multiple servers in multiple continents. So this becomes a real issue. So database and understanding how databases work is an entire field of programming. There's also DevOps. It might be a bit difficult to understand what these guys do, especially for young developers like yourselves. But it turns out that if you have a big team and you have to deploy a code into production, production is the actual environment that end users use. It has to go through multiple steps. You have to plan how are you going to develop your application. You have actual code, you have to build it. It means put all the pieces together and move it to so that it can later be moved to appropriate servers. You have to test the code, and the developers also have to write tests. You have to release it, meaning you have to assign a tag and a version to a specific release. And this becomes difficult when multiple parts are involved. Let's say you have a front end and a back end, and a certain changes must happen simultaneously in both places. Let's say some API is changing. So if you just update the back end, the front end will call this API in the sort of the previous version, but the backend would not understand it or will answer with incorrect data. So it also involves updates in the database. Let's suppose you add some information, add some tables, add some columns to the database. You adjust your backend and you also adjust your front end to show this new data. So all of these pieces must go to the production at the same time. Otherwise, you risk breaking something, and that's the deploy step. And finally, you have to manage everything, see whether everything is up and running. You have to watch out for some log information that the application is running badly, and you have to monitor that it has enough memory, it has enough CPU power, and other stuff. So all this process is called DevOps. If you just write code, but in order to move it to the production, it actually takes expertise. Robotics and IoT, Internet of Things, is one very big area where many developers are working. You can actually have your Raspberry Pi or Arduino and make some robot yourself that is a rover that can scan your room with the distance sensors or something like that. It has become affordable, both money-wise and both, well, expertise-wise. You can in fact learn very quickly how to make your own robot. One extremely giant and emerging area is artificial intelligence. So it's completely complex mess of multiple data points, as you can see in this picture. Usually, the models that we train consist of dots and strings attached between these dots, also called neurons, and all of them has some weights and numbers attached to them. So altogether, you have billions, trillions, or even more data points here, and it's impossible to make sense of it. So it's really, really difficult to understand what's going on here, and entire industry is built around this. And this is what helps self-driving cars to see, stock markets to trade, and many other emerging industries to flourish. Modern developer, starting from mid-level, I suppose, has to have some understanding how this works, because even the companies that are not directly AI related are more and more interested in what can they benefit from using AI, and this area is coming into many companies, more and more companies, and more and more companies actually have some sort of machine learning algorithm running in their backend. And yeah, also mission critical. That's a completely different style of coding, and that requires different skills. When human lives are at stake, let's suppose you're writing a code for Boeing airplanes, or for also self-driving cars, or for extremely expensive things like landing a Curiosity rover on Mars. You cannot just tinker with your code randomly and hope that it works, and if it doesn't, you will just fix it. This doesn't work like that. You have to be completely bug free, and that's why some of the code that the NASA is using is like 30 or more years old, because if it works, just don't touch it. You have to have really significant reasons why you want to touch a working code. So mission critical is an entire area, but there are several others. There is also industry of testing, how testing is done, so that you can completely test everything from one tiny piece of code to entire application, and multiple trajectories a user can take in this application. So if we try to compare salaries, this data is from 2018, you can see that the United States on average has bigger salaries that Europe, but what is common is that DevOps actually has the highest salaries here, and even though it's not clear for some what DevOps actually does, when you start participating in real projects, you definitely see what benefits this specialists can give. Also, the data scientists are pretty high on the salary spectrum. Also, full stack and backend developers. Backend developer is a developer that does backend. Full stack does kind of everything. Also DevOps, also data science, backend, frontend, which is very useful for tiny companies which doesn't need 50 developers each skilled at their tiny little thing. So full stack developers are good for smaller companies. Yeah, and front-end developers are on average somewhere lower. Um, yeah, but even then in USA, front-end developer in 2018 would have salary of 90,000 per year dollars. So pretty nice, pretty nice. And I was trying to look for programming language comparison from multiple sources. It turned out it wasn't so easy, so I just figured I will just look in GitHub because that's probably the most legit source to compare programming languages. As you can see, GitHub shows that the JavaScript is the most used language, but maybe in year 2016 it was like really dominant. Then lately the Python is catching up, and JavaScript, as cool as it might seem, it kind of works. It kind of has this monopoly on front end development. When it comes to back end development, JavaScript can do something, but it's much more crowded place there. Python is one extremely big player. You can definitely do backend development with Python. Also Java. Java is this brown line that's for all the enterprises in the world. This is the enterprise language with this is very robust, easy to test, hard to fail, and very solid language. And Python, on the other hand, is easy to build, easy to run, easy to develop. It might not be fast, it might not be secure, but it's very affordable and very easy to start coding. It also doesn't work only in the backend. When it comes to data science, it's probably choice number one with all the artificial intelligence and machine learning libraries available these days. Also, DevOps can be done using Python, and robotics. You can definitely run rovers, and you can run IoT microchips with MicroPython. That's a part of Python language. So this multi-purpose element of Python language is probably why it's so successful. You can pretty much use it everywhere. Yeah, one tool can be used for almost all the problems you can have. So JavaScript and Python, that's the victorious combination. So yeah, so what we want to check now is whether our operating system has Python and which version. If not, then we want to download it using this link. Also, as I understand, you have been working with Atom or some other coding environment. I suggest using Visual Studio Code or some of the JetBrains tools. JetBrains has the best tools for JavaScript. It's JetBrains WebStorm. For Python, it's PyCharm, and these tools are paid for, but these tools are paid, but for students they are free. But Visual Studio is free for everyone, and many say that Visual Studio is the best. Probably, I'm just used to JetBrains, but using Visual Studio could definitely benefit your coding, and it's much easier to see and everything, and to navigate through your code, and to use auto completion, refactoring, and some other tools, which we'll go through in the next tutorials. And later there is a database. SQLite is the simplest of the SQL databases. you'll see it's very easy to use it, and some sort of um, tool to work with the database. There are several plugins to work with databases in Visual Studio, but I find them not sufficient enough. So I suggest you use SQLite browser. So we will start by checking what Python version you might be having, because you might have some, you also might not have some. So you just try to do Python in your console screen like this, Python capital V, and it shows you which version you might be having. For macOS users, you just write terminal, and that should be the one. For Linux users, well, you're probably familiar with the terminal. For Windows users, to get this terminal open, you have to find the run window and write CMD there, and it should open you the command line interface. So in that interface, I try to write Python-V, and this is the version of Python 2.7.15. This is outdated version. You should probably, if you have version 2.7, it's outdated. Try to write Python 3-V, and if that works, then that's great. 3.8 is the newest version. It would be nice if you have 3.6. For purpose of these tutorials, you should have at least version 3.6 and above. Yes. However, if you don't have appropriate version, or you don't have Python at all, try to go to this link in this presentation. Yep. And you can go for download Python here. I suppose if you are having Windows, then this download link should be a Windows link, and just download it and install it. And it should, you should after that be able to run Python 3 command like this. However, if you don't, then probably for Windows users you are having some problems with environment variables. Try to Google around how to add your Python executable to environment variables. Or I will post a link in a YouTube video maybe. For those who don't use Windows, it's much simpler. For macOS users, you can just install the Python using brew install Python 3 like this. Or for Linux users, it would be apt or sudo apt install Python 3. Or if you use some Red Hat distribution, then it should be sudo yum install Python 3. So macOS and Linux have their inbuilt package managers, and you just download Python from there. For Windows, you just have to somehow find it in the internet, download and install it, and then link it to the environment variable. So it's much harder for Windows. Okay, so you have to get to the point when this Python 3-V actually works. Then, if you are really into using Atom, you can use Atom, but if you want to try something new, I suggest try Visual Studio. It will come in handy, definitely. Try to go here and just a sec. And download appropriate version for your operating system. Mine is Mac, so I have already downloaded it. I had no problems. I suppose for Windows there shouldn't be any problems as well. Once it's done, you should be able to open the Visual Studio code. For me, it looks like this. Well, how this works is you have to you have one one of these screens per one project. What you do is you create a directory where are you where your project is going to be, and one such screen is linked to one project and one folder. So you go, well, this is a new window, so you can just say that you want to open a folder. Even if you don't have a folder now, it's fine. I have some tutorials here. I will just quickly make a new one. Another project. Bam. And this is where I am. I am in my another project. This is a welcome screen. Over here it says that if you are willing to work with Python, just install this Python library. If you will be working with JavaScript, and I think we will, then install the JavaScript as well. If you forget to install it, or if you close this window, then over here is the plugins or extensions. Just go here, write Python, and install the default library for Python and Python for VS Code. It should be more than enough. Also, you might be willing to install some of these. We will get to that later. So returning here, we can create a new file. We can call it app.py. All the Python files will end with .py, and we can write the simplest possible code in Python. So print just regular braces, quotes, it's alive, and that's it. Once you have installed the plugins, Python plugins for VS Code, this button should be here, and you should be able just to run it. If the Python is installed, and if Python 3 command did work, then it should say in this corner which Python version you're having and the link to it, and you should be able to run it. Once you run it, it opens a terminal, similar console to when we were installing something over here. And it says, it prints out it's alive over here. So if you have gotten to this point, just awesome, you guys rock. And one more thing before we finish up this tutorial, we have to create our first database, which we will be working with soon enough. So let's return to the presentation. Over here is the SQLite database. We have to go here and download the SQLite database. For Windows users, again, it's a bit difficult because you have to download this installation and install it, and also if the command SQLite 3 after the installation doesn't work, then you have to add the environment variables again for this to point to this SQLite installation. But for macOS users and Linux users, again, it's easier. You just go to the command line and write brew install SQLite 3, or for Linux users it's sudo apt install or sudo yum install, depending on your Linux distribution. So if you have successfully managed to install your SQLite database, you just have the software for making the databases. You also have to create your first database. You can try to do it from this from here, but it's a bit difficult to always write commands. So it's easier to write these to manage your database from some sort of a graphical environment, and that's where SQLite browser comes in. You can try to again install some SQLite extensions for your from your VS Code, but I tried them. They are not so great actually. So I would suggest to go for SQLite browser. This one you probably have to install even if you have macOS or Linux. Just grab one. Usually for Windows users it must be 64-bit because that's the default one these days. And just grab one and install it. It should have an executable. You just double click it and you run it. I have it already installed over here. And currently there are no databases. A database in SQLite is just one file. That's it. You can actually move this database from one computer to another or send it to a friend. It's just a file. So let's create a database, new database. Awesome DB, for example. Save. And what a database is, it's in its essence just a bunch of tables. Table is a bunch of rows, let's say a user or a car or a house or just a bunch of rows that represent something. For example, we can represent a bunch of superheroes. And each superhero must always, not just superhero, anything always has to have an ID. Something that you can always find it. Something that will be unique for this guy forever and ever. So ID is pretty much by default. It's an integer, it's a primary key, which means it's completely unique for this guy. And it's nice to have it auto-incremented. So it automatically increases when you add new new superheroes, new records here. And for example, we can have a name and it's not null, so it cannot be empty. And okay, so now we have superheroes table, and over here it doesn't have any records obviously, so we can over here we have to check whether we are in superheroes table. Bam, we are. And let's make a new record. Let's say the ID automatically fills in with the sequence number 1, Batman. And currently this information doesn't exist because you haven't committed these changes. You have to say write changes because you can still revert them if you have screwed up something. So you just write them, bam. Now they are written in that file. And we can add one more. Maybe something from Marvel universe, say this guy. Again, write changes. Or you can have multiple lines and then write changes for all of them. Now, if we go here, we can go to the execute SQL. This will be important once we want to run our script that interacts with database. So you will be needing to know the simple SQL command. One of the simplest is select all from superheroes. Bam. And you have to be able to run this. and it should show that there are two superheroes, Batman and Spider-Man, with these IDs, and we will later be adding more tables, adding more columns, and adding more rows in order to work with Python and to show that data in frontend. If you have gotten this far, awesome. If not, just try to do it or try to recheck what I have said in a couple of last minutes, and hope this works out. And in the later videos, we will try to actually make an API and make something awesome. Thank you, guys.